Good morning to all. Today's topic is application of GIS in civil engineering. I, CHANCY, currently studying in M.Sc Geoinformatics in ISTAR. I have pursued my B.Tech in civil engineering from Birla Vishwakarma Mahavidyalaya. I would like to thank Krunal Suthar sir, ISTAR College, CVM University, ISG chapter Vivinagar for giving me this opportunity and conducting such a webinar series. Today I will discuss about civil engineering, GIS project life cycle, application and use of GIS in urban planning, development, surveying, environmental engineering, impact and studies, civil site selection, how use of GIS in transportation and planning, method of soil mapping, need of critical infrastructure, protection, demo on terrain mapping and analysis, utility management, and at last Q&A session. I would like to announce that attendance link is open for 15 minutes. You can mark your attendance. Civil engineering is a discipline that deals with design, construction and maintenance of all infrastructures. Civil engineering have to work with the voluminous amount of data from variety of sources. As per current scenario, since thousands of years civil engineering is existing, we know about Lothal and Harappa city, even they have a good knowledge of civil works. Today, we are in the era of high-tech technology for smart, smooth and efficient output in civil engineering. GIS is a geographic information system which is designed to capture, store, manipulate, analyze, manage and present spatial or geographic data. GIS allows user to create interactive queries, analyze spatial information, edit data in maps, and also present it in the form of chart, report, etc. For GIS, need GPS and remote sensing data, along with the skills of software such as QGIS, ArcGIS, ADAS, NV, etc., which lead us to an actual GIS expert. As already in previous webinar session, we discussed about point, line and polygon, so I am not discussing here. Any construction project has a life cycle. GIS is playing an increasingly important role in civil engineering for supporting all phases of infrastructure life cycle. GIS can be used in each stage of this project. Life cycle starts from planning, where GIS is used for surveying, data collection, site suitability and many more. In design phase, used for analysis and modeling. Here, predefined rules in software can avoid the mistakes done by the human being, just like we civil engineer uses AutoCAD. In construction phase, used for tracking ongoing activities and also to monitor the structure day by day. Day by day use of construction and consumption of raw material. Even for longer construction area, drones are very useful to keep an eye on the field. Finally, GIS is also used for building and smart home, Google Home automation, parcel delivery by drone or robot at doorsteps. Overall, GIS can be used for management of whole project life cycle. Today I will discuss the use of GIS in all the phases. Planning. Planning is the most crucial stage of any project. In planning, GIS can be used for site selection. For example, to open a new school or college, minimum 3 meter per student space is required as per government norms. So if we are planning for 1000 students, then you need minimum 3000 meter square space. So first, your digital plan automatically shows you in city where total open space is 3000 meter square or more. Then we can choose near to main road, then add new layer of utility available in respective plots, then surrounding hazards and etc. layer added one by one with the help of better site selection. Large mega stores like DMart, Reliance, Chroma, Amul, etc. uses GIS technique for best shop location in the city. Environmental impact can be measured on very large scale using satellite data. Government initiative for ecosystem established going on a right way or not can be monitored and find out damage to help ecosystem. Is there any sustainability issue like landslide, riverbank erosion, increasing salinity can be detected. AI helps to managing the traffic congestion, but GIS based AI gives a perfect solution. Data collection. To make a project successful, a precise and accurate data is required. And GIS help to collect such data related to topography, hydrology, wetland, soil, etc. using a technique such as satellite images, LIDAR, photogrammetry, GNSS, drone and many more. In past, all data is paper data and post-processing data only. Then it reached to Excel digital data. In GIS, it's location-based data. So apart of GIS, any team member can see live data update and can do analysis. Analysis and design includes integration with traditional GIS, design tools such as CAD and database for new design capabilities, to create a data for civil work including grading, contouring, specification, cross-section, design, calculation, mass haul plan, environmental mitigation plan and equipment staging. Analysis and design. For water distribution on earth surface in river, canals and branches of rivers are easily monitored by GIS system. We can measure water quantity, turbulence and volume of water. For example, water volume dispute from Krishna river between Karnataka, Telangana, Andhra Pradesh and Maharashtra, Mahinadi river dispute between Odisha and Chhattisgarh, Ravi and Beans river, etc. Many more disputes we can resolve very easily and technically for smooth function. Of course, we use geointelligence for traffic network and fast operation of vehicle on road. At sequentially triggering on and off of time for red and green signal is controlled by geointelligence. Soil analysis. For soil fertility and land use land cover, we can measure even with 50K resolution. Land use land cover map is available for public for multi-satellites like Landsat, Sentinel, LIS-3 and many more satellites. GIS can be used for environment impact analysis to trace the gases ozone, sulfur dioxide, nitrogen dioxide, carbon monoxide, methane, as well as aerosol in the Earth's atmosphere. Even we are able to measure and forecast the temperature, humidity, weather, and all use satellite system. This all satellites gives an image and is open with the help of GIS software. As well as per location, it is broadcasted for public. Using GIS, water distribution from state level to society level, soil stability, digital elevation model, easy to design gravity, canal and its pattern, impact of high rise building, sun reflected rays, temperature on surrounding environment, etc. and many more design and analysis can be performed. Construction phase, where layout, plan and design came into real existence. In this, GIS can help to do resource optimization by timely use of construction equipment, by checking the seasonal fluctuations, by optimizing and real-time tracking of routes for concrete dumpers using GPS live location in control room, for quantity analysis of earth filling and cutting using drone, LIDAR, and also calculating the volume and area of constructed phases. While the Palm Island of Dubai was in the construction phase, they used GIS technology for pouring the sand dunes at an appropriate location as well as rate. For example, if we need a 150 truck raw material for a one day, then we may order that much only and there is no requirement of the storage space on the site. Operation is used to control the project by modeling of site data and compared by the baseline prepared in planning phase. GIS helps to make a record of work that has been completed and can visualize in the form of thematic maps, which will guide about rate of operations, completed operations as well as pending operation. It utilized by all time line project from few months to few years. A project life directly affects the project cost, health of machinery and profit margin also. So continuous operation is very important. Monitoring and maintenance is an essential part of any civil project. GIS is used for monitoring and maintenance of important infrastructure like large building, dams, canal, bridge, utilities like electricity, water supply, pipeline, sewage pipeline, etc. Here in the figure, you can see a permanent GPS is installed on the dam and real-time satellite data is captured to monitor the dam and slope. The data is transferred to office and analysis is performed for further operation for maintenance. Any stretch bend is found beyond the certain level, automatic GIS predefined algorithm alert in control room in next few seconds. In past, some tasks were performed by theodolite or total station, which all we have used. As per time, interval of week or monthly survey visits are taken and reading a specific point. They survey back to office and post the analysis of data. If during time interval anything happens, no one have idea. In case of heavy monsoon or very bad weather condition, live monitoring of dam bridge building is most useful to take the necessary steps. Parcel selection and display tools available in GIS allows to visualize the scheduled work for maintenance, ongoing activities, recurring maintenance problem and historical information. The topological characteristic of a GIS database can support network tracing and can be used to analyze services that may be impacted by events such as stoppage, main breaks and drainage defects. Management is a crucial to make a project successful. Having a clear and accurate 3D picture of a project helps to understand better, minimize problem and mitigates the environmental impacts and cost. If the cost is controlled, then profit margin is also increased. Hence, overall benefit goes to the company or customer. It saves time and cost and helps the decision maker to take a step as GIS presents the information in a straightforward manner to all the stakeholders of the project. GIS plus BIM integration. GIS is Geographic Information System and BIM is a Building Information Modeling. Is integrated and used to interpret and combine data from many different formats. It also integrates CAD drawings, satellite data and parcelling map to produce a visual object. Let's watch a quick video of GIS and BIM integration. As we saw in the video, the integration of GIS and BIM and its importance for the completion of whole project life cycle. Application and use of GIS. There are n number of application and use of GIS in civil engineering in whole world. Each stage and phase of life cycle of civil project. Today I will discuss few of them. The discussion of different application is not only limited. I try to justify the important application of GIS in civil engineering. Urban planning and development. Let's begin with the first application. The exceptional growth of Urbanization has caused several problems of sanitation, power, water supply, housing, environmental pollution, and disposal of effluents. For sustainable development of urban agglomeration, ideal resource development model and urban land use plan need to be generated by integrating the information on demographics, natural resources, socio-economic statistics in GIS domain. GIS is used to develop, implement, analyze, locate and monitor urban growth and its direction of expansion. Can be also get suitable site for urban development for sustainable decision making process. The urban development of the smart cities also are based on GIS. In the left image, you can see the old urban development paper map and in right side a digital interactive map which are prepared nowadays using GIS. So on fingertip you can calculate area of residential plot, total carpet area, road width, length of road, suitable public garden and its space, its area, minimize the route and road, even predict for urban sprawl development using a digital model and all the previous year's data. Several different layers such as land use, land cover, built up area, electricity, water supply, road, open area, commercial area, sewage, etc. can be integrated into GIS for urban development analysis and monitoring. 3D modeling of city makes a city ionic for others, and 3D modeling with location based is used for better decision making of metro cities, for designing of flyovers, to find the airport sites and all other useful building sites. Next application, that is surveying. Surveying is the measurement of location of object on the earth's surface. Global navigation satellite system known as GNSS, which includes GPS, GLONASS, Galileo, Baidu, IRNSS developed by India. The data are collected through the receiver of GNSS for measurement. GNSS is used for topographic surveys where a centimeter level accuracy is required. This data can be incorporated in the GIS system and real time if the dynamic data collection method is used. Update can be checked at the real time and any missing measurement be captured, which was not possible in the old GIS system where we used to take the total station to the field. And again come back to the office and do all the analysis. GIS tool can be used to estimate the area and prepare digital map. For level accuracy, LIDAR can also be used. LIDAR gives us the level accuracy. Environmental engineering and impact studies. Civil engineering develops the structures and system that produces a potential adverse effect on environment. At the same time, we must be conscious about the impact of this work we can have on environment. Environmental impact assessment is required for all projects as per government law. Environmental impact studies relies on physical data, geological data, biological data, social data, historical data, future development plans, industrial concern, and other data which can be integrated in the form of layers, and analysis can be performed to make an effective decision that have the least impact on environment. GIS also permits to view the satellite data and carry out spatio-temporal analysis along with the prediction, trend, pattern, and relationships that weren't evident without the visualization of data. Best example I give is Dubai city. As per one study carried out, city temperature is always high than the surrounding desert area. After so many analyses, it was shown a result that large and high-rise building uses glass which reflects more sun energy, and tilted glass add more IR ray reflection too. Hence, surrounding temperature of glass coated building is very high. In the city, for better look, less weight, and for controlled temperature inside building, engineer uses more glass building as it looks attractive too. So Dubai government give a guidelines for the use of specific type of glass only in building construction. GIS was used here to carry out this hotspot analysis and to take a better and a balanced decision for environment. Site selection is one of the basic vital decision in any project, as location is crucial point on the road to success or failure of project. With GIS, various layers can be integrated and can identify which place is suitable for project. As most of the data used for site selection are geographically correlated, it provides GIS analysts to identify a list of suitable sites for future further investigations. For hilly area, we look as construction are hard life, but same hilly area is also used for recreation like paragliding, snow skating, and hence even on hilly area, site suitability for construction as well as better view can be selected very easily. Nepal airport is one of the best example. In short distance and on hilly area, they make a runway. Nearby airport runway, there are many mountains, and due to high volume generated during airplane landing and takeoff, landslide may occur in the area. So, by using GIS, sound analysis can be carried out so that precautions can be taken and prevention can be done. Why to use GIS for site selection? We have various other techniques for site selection, but GIS gives a faster decision making process, enhances the accuracy, saves the time, it is cost effective, simple to understand, it can be done repetitively, evidence based outcome as it works in the form of layers, clear communication with stakeholders and public. This all categoristic GIS software predict the answer, shows a clear result to us. As explained in earlier slide, recreation as sports or hotel for site selection and construction at hilly areas. Collect all the data such as drawings, contour, that is triangular irregular network, then do the modeling of existing structures and facilitate and integrate it with TIN model. Then in the step 3, create a layer of land use and land cover, subsoil, power supply line, existing buildings, road network, elevation data from contours and any other specific data if required. Then set the various criteria such as distance from road, distance from existing building, slope, availability of electricity, water distribution pipeline, street lights availability, and as a result of this criteria definition, categorized map will be obtained, and from that maps, that is layered, overlay analysis is carried out, and finally output is obtained. That output can be further be filtered, and then the site can be selected. Transportation planning. The use of GIS in transportation is widespread. GIS significantly aids in planning, monitoring, managing complex systems involved in transportation planning and management more efficiently. It manages and monitors road, railway, waterways and logistics by using environmental and topographical data. In the GIS platform, the major area of application includes highway maintenance, traffic modeling, accident analysis and route planning. CCTV camera captures a traffic on road, and after digital image processing, which is a part of remote sensing and GIS, it automatically updates data in system as per location. Here, artificial intelligence AI algorithm keep open road as green light on same lane where previous signal showed traffic. It avoids more traffic jam. Hence, here CCTV camera location and junction are important point for analysis, and on and off time automatically change to reduce traffic jam on specific lane. This is actually used in various cities in foreign. For example, traffic is more in early morning city to commercial area, and at evening commercial zone to residential area is more. So likewise the algorithm can be defined or designed, and the steps can be taken. With visualization of real-time data, transportation planners can easily identify the potential issue that can be addressed more efficiently and economically than with the existing methods. Though detailed GIS maps, this information can be easily conveyed to decision makers and the public. It helps to manage municipality annual budget where overfly needed the most or where we can delay for a new overfly. As per city and population expansion, new public transportation route can also be added. Best example is Uber and Ola, which we all have used, uses the GIS and GPS technology for developing their own business, and today they are at the boom. In planning for a new railway or road network, analysis can be performed by adding environmental and topographical data into GIS platform. Output with best route based on criteria like flattened route, least damage to habitat, least disturbance from local people, etc. GIS can efficiently use for management of traffic problems. Today's population, along with the road traffic, is increasing exponentially. The advantage of GIS is it makes it an attractive option to be used in the face of emerging traffic problems. By creating a database that has all traffic information such as speed of data, road geometry, traffic flow and other spatial data, and processing this all the information provided as a graphical bigger picture for traffic management, for effective traffic management. Accident and hotspot analysis can be used to minimize the accident hazards on road and saving the life of people by identifying the accident location and providing a remedial measures to minimize the accident. Rerouting the design is also very convenient using GIS. Here I would like to give an example of German road named Autobahn, which is one of the road in the world having no speed limit officially. Hence, possibility of major accidents are more. Hence, as per government planning, they use air ambulance to save a life, not simple ambulance on road. So from the whole world, driver came here for thrill and enjoy their patience. Here, the air ambulance uses the digital image processing as well as GIS and GPS to track the location if there is any accident. Soil mapping. Soil mapping provides resource information about an area. It helps in understanding soil suitability for various land use activities. It is essential for preventing environmental deteriorations associated with misuse of land. GIS helps to identify soil types in an area and to delineate soil boundaries. It is used for the identification and classification of soil. Soil map is available by government on Bhuvan website, which is authentic. Soil map is widely used by farmers in developing countries to retain the soil nutrition and earn maximum yield. Critical infrastructure protection. GIS technology offers sustainable responsive tool for combining information from flood aviation, elevation route to inspection results and structural specification. It can use GIS tool to analyze and combine specific data required to complete a task. Add weather data and current traffic. Draw a barrier protection region and share new changes in actual time in GIS platform. The security and safety of the building are in the hands of civil engineers. Utility, bridges and other critical infrastructure requires a comprehensive decision-making equipments for preparation, response, emergency assessment and recovery activities. Terrain mapping and analysis. GIS enables engineer to identify optimum location for development of terrain area and to make a detailed analysis without stepping a foot on the location. Assessment of the performance of the terrain for specific developmental activities can be made through terrain elevation model, also known as DEM, digital elevation model. The information on regional engineering soil is essential for general planning and site evaluation purpose. High resolution data, satellite data, can be used for analysis. Data such as Cartosat, SRTM, ELONS can be used. Contour, which represents the elevation, is one of the important maps required for terrain analysis. In the left image, old contour maps can be seen, which is prepared manually, while in the right side a digital contour map is prepared within a fraction of time as well as more accurate. Let's see a live demo of how to prepare a contour using QGIS software. Here I will add DEM by Cartosat. Okay, so the Cartosat data I have downloaded from the Bhuvan website and I am adding that raster data. Yes, so this is the DVM data you can see. Now I will generate a contour from this. Here I am giving the contour interval as 50. You can give it as 1 meter or 10 meter as per this project requirement. So the algorithm is processing and the contours will be generated. Here the DEM data used is of Cartosat 3, which has the spatial resolution of 30 meter. Also we have various free available satellite data of 10 meter resolution also. The various analysis along with the contour such as slope, watershed analysis, aspect analysis, sound analysis, all can be carried out using GIS software, as well using GIS software such as QGIS, ArcGIS. Here, the contours will be extracted in the form of vector layer. The vector layer will be in the form of line data. Then that line data can be used for categorization for any further analysis. The algorithm is processing the whole DEM file, which is having the lowest elevation as 499 and highest elevation as 7575. This image is of an hilly region of India, Himalayan region. We can also prepare the digital elevation model 3D model using DEM as shown in the picture in the slides. The 3D, the height given by the contours can be accelerated relatively, and a defined 3D model can be done for getting a better view of the terrain area. Here the image is very large, so it is taking some time for the algorithm to process the whole image. Okay, we can see here the contours are prepared. Now I would like to show you the label. I would like to show you how contours look. Yes, so now we can see the contours. I am zooming it so we can visualize the whole contour. Here I would not categorize the contour. Yes, so see, we can see here the whole contours are prepared and how it looks. Yeah, see, within fractions of minutes we have prepared the whole contour map of the Himalayan region, and the further analysis can also be done on these contour maps. So let's go to the PPT. Utility management. Utility management. GIS is used for utility mapping, inventory system, track maintenance, monitor regulatory or model distribution analysis and load analysis. GIS application can integrate with hydrologic and hydraulic modeling data to provide a detailed analysis of water utility system. Even GIS based model help to do all. For example, in India, most of the basic utility are installed by government, and government engineer job is transferable after 3 to 5 years. If all maps are prepared, all maps are paper map, then accuracy and life of paper map came into a picture. If GIS, GPS enabled updated map are prepared, after final construction, along with the depth of the pipeline installed and other parameters. Then, if any non-technical person came, then also able to exactly extract where and what the utility is installed, such as water, sewage, or any other utility. Nowadays, government is using whole GIS based system for installing and maintenance the gas pipelines in various cities. This system is also used for the underground electric cable supply. Pipeline route selection. GIS least cost path analysis have been effectively used to determine a suitable oil and gas pipeline routes. An optional route will minimize a reduced economic loss and negative social environmental impacts. Locating underground pipeline and cable, GIS is very useful, as pipeline and cable location is essential for leak detection. Pipelines are continuously monitored and checked from leak detection and avoid the problem of geohazard like breaking of underground pipeline or leakage of gas. GIS technology is faster, better and more efficient in this complex task. Accurate pipeline route selection brings about risk and cost reduction as well as for better decision making process. Here in the image you can see the use of old laying of pipeline or for maintenance. We have to dig all the pipelines to get exactly where the leakage is. Whereas if we have the GIS enabled map, then a small coupling or any small junction is made can be marked on the GIS while construction and can be used further for any other maintenance purpose or if there is any leakage. The SHAH data are extremely used for the utility management of pipelines. If there is any leakage, the soil around the water will be wet and can be easily detected using SHAH data. Few references I used while making presentation. Thank you. All the answers are actually given by the Krunal sir in chat box, so no need of any question answer session. If you have any further query, you can mail me on my email ID shahchancy28@gmail.com.